Hello and welcome back to Mrs. Ogram's Maths. This video is going to take you through an integration set of parallel questions that are focused on achieved and merit. So these are the first three parts of three questions written in a very similar style to the external. So the first two parts will be where your achieved points are, and part C of each of the questions is worth a merit. And then across the paper you can get achieved and merit. Right, so we've got just some straightforward integration on this first one. So we raise the power by 1, divide by the new power. Now remember that this is something that's on your formula sheet. So something over x goes to ln x, and because we have the 4 there, we've got the 4 in the front like so. And then minus 10 becomes minus 10x, and finish with a plus c. Right, part B.
So if we start by putting that acceleration into power form here, we're doing kinematics. So to get the velocity from the acceleration, we will integrate. And to integrate this, we raise the power by 1, we divide by the new power, and we also divide by 1, which is the coefficient of the t in here. So we get 0.8. This will have a plus c on it, and then we need to work out what c is. Now, I've realized that I've actually made this slightly trickier than intended. This would probably fall more towards a merit question than an achieved one, because we do need to work out that plus C. So my apologies there. In trying to write a parallel question, I just made it a teeny bit harder than an achieved. Okay, so next thing, we know that when that the information we've got is from when the object started to move. So it will have a speed of 0 when t is 0. So we get this is true. So then we can put that into the equation. So if we put t is 0 into here, we set it equal to 0, then we can solve for c. Okay, so then we get that c is minus 21.6, so put that back into our velocity equation and substitute in for 7. And then we can work out that velocity is 29.6.
Okay. For this merit question on part C, we need to separate out as much as we can of that fraction first. We're going to do a little bit of algebraic juggling to make that easier to integrate. At the moment, we can't integrate it straight away as it is. Okay, so I'm going to start by changing the top line into things that are to do with what we had on the denominator here. So to make 2x, we need that 2 multiplied by that bottom line. So we'd get the 2x out of this bit here. It would also give us a minus 2 when we do 2 times minus 1. But instead of minus 2, we want minus 3, so we need to subtract another 1. So that would be equal to, we can separate out those two things, so it'll be 2 over x minus 1 minus 1 over x minus 1. Oh, whoops. Sorry, just a whole 2, not 2 over x minus 1. So separating out this part here, and the x minus 1 over x minus 1 cancel, and this part here. Now we can actually integrate it. 2 becomes 2x. This becomes minus. Now this is something over something to do with just like singular x, no powers of x. So that will be to do with the natural log of the bottom. And then we consider what's happening inside of that function. So we don't have any powers of x, we don't have any coefficient of x, it's just a 1, so we don't need to adjust anything down here. And now we'll substitute in. And we'll get the final answer 4 minus ln 3, or 2.9. Right, question 2, we're going to integrate this thing, and I'm just going to turn it into powers first. So 5x to the minus 2 like so, and pi by 2. Okay, so 5x to the minus 2, increase the power by 1. If we increase from minus 2, we get minus 1. We divide by the new power, so we're dividing by minus 1, gives us a minus 5. Oops. Okay, now pi by 2 is just a constant, so this just becomes minus pi by 2x and then plus c. Okay, Simpson's rule here for part B, so I'm just going to pause and add in the rule itself. I'm just leaving it at the top of the screen for us there. Okay, so if we're going to do our integral, it's going to go between 0 and 4.5. We can either work out h using this from doing the last minus the first and divide it by how many we've got, or we can just simply look at the gap that we've got between these. So this here is h, so h is equal to 0.75. Okay, so integrating our function is going to be a third times by 0.75, and then put in the first y term, so 0.8, the last one 0.9, 4 times all of the odd ones, so that's 1.3, 2.4, 1.5, then 2 times all of the even ones, 1.7 and 2.2. And I'm going to pop that in the calculator. And if you take a look at the lines I've got in the calculator there, you can see I don't put this all in one go because that's likely to come up with just user errors of forgetting some brackets or something. I work it out in stages and then do it in pieces as I go. So that gets us to an answer of 7.575. Right, part C, a merit question. Here we go. So we're going to work out the value of k that makes that equal to 2 ln 6. So we've got this fraction, and the key thing to recognize here is that the top is 1 less power than the bottom, which means that the top is a multiple of the derivative of the bottom. If we differentiate the bottom, we get 2x. On the top, we've got 4x, so that's just twice as much. So we can use the natural log, and I mean, you've got the clue here because that's going to be equal to something with natural logs too. Okay, so if we integrate it, it becomes something to do with the natural log of the bottom, x squared plus 2. Now, if we did differentiate that inside, we'd get 2x, we want 4x, so we actually need to start with twice as much of that. Okay, now if we apply the limits of the differentiation, 1 to k, then we can substitute in, we would get 2 times the natural log of k squared plus 2 minus 2 times the natural log of 1 squared plus 2. So we get 2 times the natural log of k squared plus 2 minus the natural log of 3. Okay, now if we subtract logs, it means we can put them together and divide. Okay, so now if we match that up to what we started with, 2 ln 6, then k squared plus 2 over 3 must be 6. So k squared plus 2 is equal to 18. So this will be 16. K would be plus or minus 4. Now, since we are told it's actually an upper limit, it must be higher than 1. So k is equal to 4. Okay, 3a, integrating cosec squared, that is on your formula sheet. We know that if you differentiate cot, you get negative cosec squared. So if we integrate cosec squared going backwards, we will get a negative cot of 3x, and then we need to divide by the 3. So it'll be negative a third cot 3x plus c. Right, if f dash of x is equal to e to the 5x and y is to, we've got a coordinate to be able to help us work it out, find the value when x is 1. Okay, so f of x, first of all, if we integrate that thing, would be 1/5 e to the 5x plus c. Now we know f of 0 will equal 2.2. So 1/5 of e to the 0 plus c will be 2.2. Well, e to the 0 is just 1, so 1/5 plus c is 2.2. So c is 2. Make sure you don't stop there. We now need to work out the value of that function when x is 1. And I just realized I switched my notation there. I shouldn't have said y. I should have actually put that as f of x. Okay, so then f of 1 will be 1/5 e to the 5 times 1 plus 2 comes to 31.7. Okay, part C. The graph below shows this particular curve. Find the shaded area. Okay, so we need to be able to integrate it between this point and this point. So we need to find those points of intersection first. So 2 over x plus 5x being equal to 11. So if I times everything through by x, we get, oops, not plus, we want equals 11x. Okay, now rearranging that into easier to see quadratic. And then we'll go ahead and try and solve that. You can use your calculator to help you out there, I guess. But it's a straightforward factorization there. So x is equal to 1/5 and x is equal to 2. So that is 0.2 up to 2. Okay, now let's integrate it. So we have the integral between 0.2 and 2 of 2 over x and 5x. That's equal to 2 ln x plus 5x squared over 2. And then we'll substitute in our limits. And that comes to 14.5 units squared.
Under curve, that would be the 14.5. So we need to subtract it from this rectangle here to actually find the shaded area. And that comes to 5.3 units squared.